Hi there, this is Jacob Nash, Precalculus Lessons, and this is Unit 0, Lesson 3 on Solving Equations Review. So, for some of these, you probably would still know that because you have known how to do this for years, so probably you wouldn't forget that. But some of these, oh my gosh. Sorry about that. Just looked out my window and there's a shopping cart in the middle of the road. Hopefully no car crashes into it. Don't know who did that. Oh my gosh. Someone seriously almost hit it. I'll probably move that after I make this video. So, you know. Anyways, back to what I was saying. We need to isolate the variable. That's how you solve an equation. So whatever letter you see, figure out what it is. That's what you do. Also, you might have to factor and the degree, which is the highest exponent that you see there, shows how many solutions you'll have. So if it's a 3, then you'll have 3 solutions. And we'll see how that works. So for these, I put the answer on there already, so we already know what the answer is going to be, but I'll just put that there so that, like I said before, I sometimes make mistakes, and I've already worked out these problems, and I know the answers, but in case I messed up on here, I would know. So, for this one, we want to find the x, but we're going to need to distribute first, and that shouldn't be something new. Once again, this is a refresher, so if you want more information on this, you might want to see Jacob Nash Algebra Lessons. So, that would give us 6x plus 12, then plus this 8x here, equals 4x plus 4 plus 8. Now we can combine like terms. We have to combine these two. That would make us have 2x plus 12 on this side. And on this side, that would make us have 4x plus 12. Already, I did something wrong, I think. Yeah, I did. This would be 2x, not 4x. I don't know where I got that from. So you see, that's why I had the answer there. Otherwise, I would have just probably left it like that. And right now, since we have the exact same thing on both sides, that we don't even really have to do anything else, because that's going to be infinitely many solutions. But just to show you how that is, you subtract the 2x, and that cancels them out, because that means 0x. And then 12 equals 12. And whenever you have a true statement like that, that means infinitely many solutions. So any solution works for that. So you might get that. Anyways, this one, right here, we should have had, that would have number 1 should have had one solution if there was an infinite okay, you know, I can't talk today, can I? I just said it earlier, infinitely many solutions. So there you go. Distribute again here. Let's make it go up a little bit. So that's 24x plus 9 on this side. On this side, hang on. I think there's a problem with this. Okay. There's something wrong with this problem. That's for sure. I don't think that 24 is supposed to be there. I think I know what happened. Okay, let me look here. I have the thing on here, so that starts with 3x. Yep, okay. You want to know what happened? This dumb Microsoft thing that I'm on, it saw 8, and it thought the x meant times, and then it saw the 3, so it put a 24 there That's happened before, but I usually catch the mistake. So there's no 24. Sorry about that. Ugh. Some things are really dumb about this, but all technology is like that anyways. Alright, so -5 and then plus 20x plus 5x. That would give us, when we combine like terms, 24x plus 9 and then 5 and then 25x. -5 plus 25x. Then we would get the x's on both the same side. Alright. 9 equals 5 plus x. Then we add 5 to both sides to make that x alone, and we get x is 14. So that's the right answer. Good. This one, so hopefully 1 and 2 are things that you definitely remember. 3, though, that's something you only learn in Algebra 2 probably, and so you might not remember it. And a lot of teachers teach this dumb ways, but the way that I show you hopefully makes the most sense. So, what we want to do, we have fractions here, and we can't solve like normal because we see 2 x's and we want to combine them, but we can't do that because they're on fractions. So we have to get rid of the stupid fractions because they're dumb and they make it annoying. So how do you even do that? Well, the way that we do it is if we make all the denominators the same, we're able to just forget about them. So, how can we make them all the same? We see 3, we see 4, and we see 2. Usually, the highest, what you can do is the highest numbered denominators, you just multiply them. So 3 and 4, they're the highest ones there. 12, does that work for 2? Yes, because 2 goes into 12, also 3 and 4. So that's the common denominator. If you really want to get technical about it, if you have 3, 4, and 2, you just basically multiply it by 2, and then that would give you 6, that would give you 8, that would give you 4, and you multiply by 3, starting from here. And then you get 9, and then you get 12, and then you get 6. Then you multiply by 4, 12, 16, now 8, and then you multiply by 5, that would give you 15, 20, and then 12. And we see 12, 12, 12, there's something that's on all of them, so that's how you know it's a common denominator, if you want to get technical. But usually you can just tell that a number that can go into all of them. Now, what you don't do is you just multiply all the things by 12. No. You figure out what you need to multiply the denominator to make it equal to 12. So how can we make 3 12 if we multiply it by 4? How can we make 4 12 if we multiply it by 3? How can we make 2 12 if we multiply it by 6? So you do the same thing to the numerator. That's what you have to do. So 4, 3, and then 6. Now we can just say, dumb, goodbye. So now we have 4 times x minus 2 plus, we got that plus from there, 3x. Keep in mind if this was a minus, you would need to distribute the negative. And then 6 times 1 is just 6. Now, distribute this, 4x minus 8 plus 3x equals 6. Combine the 4x and 3x, minus 8, 6, add 8 to both sides, divide by 7, that's your answer. So, and just to check it, if we do 2, we plug into 2 for the x, 2 minus 2 is 0, 0 divided by 3 is 0, 2 divided by 4 is 1/2, so 0 plus 1/2, does that equal 1/2? Yes. So you can even check your answer if you want. So it's not as hard as it seems. See, teachers try to make it complicated than it is, more complicated than it is, but that's the simplest thing you can do. All right, now here So also keep in mind, what was the degree? All the x's had an exponent of 1, so there only should have been one answer. Good. Here, right now, we have exponents of 1, but that doesn't mean there's going to be a the degree is not 1 because we're going to multiply these two things, and when you multiply, you add exponents, so 1 plus 1 is 2 of the x's there, so we should get 2 answers, and as we can see, that's what the answers will be, and that is 2. So we should get 2 answers. We can multiply these two factors by using FOIL, which you also can do the box method, but F means first, so the first term's there. X minus 2x is 2x squared. So that now we see that squared. There you go. Know that that's 2. So then we have the outer, so the ones that are on the outside, x times -1, negative x. Now we have I for inner. Positive 3 times 2x is 6x. And then last, L is last, so the last 2 minus 3. So there you go. That's how you do FOIL. Now, oh yes, equal to 4. Don't forget about that. So this is a quadratic, so we can solve by factoring, even though we just unfactored, because that wasn't really a factoring. Because this 4 was on the other side, we couldn't factor it in a way that we can make our answers. Because to find the answers when you're doing quadratic, you have to make a set equal to 0, and just subtracting the 4 wouldn't do anything. You would get different answers than what they actually are. So that's why you have to do this. So if we need it to equal 0, then this 4 is going to need to come around and be negative. Negative 4, so that would make it minus 4 right here. So 2x squared, you combine those, positive 5x, minus 7 equals 0. There we go. Now we need to factor. And we can factor using what's sometimes called the bottoms-up method, but I just made a factoring video, it's lesson 2. But I can't go into much detail right now because pretty much you're supposed to already know this. But what you can do is you can't use this method, you can't do anything until the coefficient here is 1. So to get rid of that 2, we multiply it by the -7. So we do x squared plus 5x minus 14. You just need to remember that at the end you'll need to divide by that 2. Now, oh, low battery, that's not good. We make our 2 factors. What I like to do is just this. So x, I know that looks like x minus blank, but we always know it's going to be x something blank, x something blank, and I just make it a minus sign because I can change that to plus easily, but if it already was a plus, then I can't change it to minus easily. So we need to figure out what 2 things can multiply to equal 14 that add to equal 5. Well, we think of 2 numbers, 2 and 7. When those numbers are combined in a certain way with certain signs, they can equal 5 and they can equal -14. Since this is -14, the signs of both factors will have to be different. So is this correct? Let's see. So positive 2 times -7, that is -14, is positive 2 plus -7, positive 5? No, that's -5. So this one's got to be positive. So that's what your factors are, still equal to 0. And then divide by that 2 from right here that we used earlier. And that would turn out to be x minus 1. And then it could be, you could do this, but typically you don't want to have fractions in there. And so you just basically, you put the 2 by the x. Then what you would do is, I'm going to go over here, set each factor equal to 0. So this is the first factor, x equals 1. And when you would solve that, you would see x is negative 7/2. That's your two answers. That's how you do a problem like that. Last one, this one. Since our highest exponent, or the degree, is 3, we should get 3 solutions. Alright, we should solve this by factoring. So we should get this, make it equal to 0 on that side. So make the 3 go on the other side. And it's like this. Now, since we have 4 terms, let's try to group both two terms. So right here, you can divide out, can you divide out a number? No, because there's 3 and 1. That doesn't do anything. X to the third, that really means x times x times x, and then x squared, 2 x's. We have 2 and we have 2, so we can factor out an x squared. So that really just means we're dividing out it. And we know when we divide, we subtract exponents. 3 minus 2 is 1. So, well, that's what we were doing. So 1, x to the first. Then we still have the 3, and then those 2 cancel out. So we have that there. Here, we usually don't want to have a negative on the first term, so let's divide out a negative, which really means negative 1. But all that does is change the sign of it. So we have a minus 1, and that would change it to this. What's good is that this is the same. So now we have x squared minus 1 is one of our factors, and x plus 3. So you might say, oh, I thought we were supposed to get 3 answers, but there's only 2 factors. Well, you have to see that this is a difference of perfect squares, so there's going to be 2 within that. Or you could just set this equal to 0 and know that when you get this and you take the square root, that you would get positive and negative. But the way that you usually want to do it is just to see that that's a difference of squares. So you take the square root of everything there. Square root of x squared is just x, and then square root of 1 is positive and minus 1. So we would get those factors, and then set equal to 0. And when you set each of these equal to 0, you pretty much just change the sign of what it is. And these are your answers. So that is solving equations. So for more help, please see Jacob Nash Algebra Lessons, or just feel free to look up any other video, but hopefully this helped. That'll be it for this video, and thanks for watching.